Hello guys, this is going to be question 1 on your homework. The information part of the question is missing, but there is not much of an information actually. So you have an object initially going to the right with v0, and there is a force acting on it as negative kV. And initial location is given as 0. And they're asking for initial acceleration. So in part A, all you have to do is write Newton's second law of motion, total F equals mass times acceleration. So they're not asking for velocity, they are directly asking for acceleration. So all you have to do is just write down all the forces acting on the horizontal axis. So the only force, there's a friction on the surface, they don't say anything about friction, so the only force acting on the object is that force, which is kV, and that's equal to mass times acceleration. Then my acceleration will become negative kV over m. So that is basically part A. And in part B, they are asking for velocity is a function of time, so now I need to write down my differential equation. So my differential equation will be basically negative kV equals, because that's the only force, equals mass times dV over dt. Alright, so my force, this is the only force, equals mass times acceleration. So this is my mass and this is my acceleration. So I just write my acceleration in terms of v, and that is going to be dv over dt. And now I need to solve this equation. So, but that is going to be a little bit simpler than the others because we are not going to need u substitution. So you just take this dt to the other side and then take this kV to this side. Or, alright, let's do it that way. So dt equals m dv divided by kV, but there is a negative in front. So over here, it is going to be very simple derivative actually, because as you can see there is only one thing. On the previous ones you have a minus something, but now you just have one function. So that means that integral can be done simply. So all I would like to do is just get rid of this negative mk. So I'll just put it to the other side. So to be able to take it to the other side, I just need to multiply it with the reverse, which is k over m, and you'll also have a negative, so you multiply with the negative. So my entire thing will become what? Negative k over m dt equals dv divided by v. So now this negative k over m is a constant, so I don't need to include it into integral. So you take the integral of both sides to get rid of the derivatives. And now we need to figure out my initial and final boundaries. So I'm going to start at time equal to 0. And when time is 0, my velocity is not 0 this time. What's my velocity when time is equal to 0? It's going to start from v0. And it's going to go from 0 time to any time t, and it's going to start from v0 and any velocity v. But we were using primes to describe those, so it's just going to be primes. Then previously I have solved this one already, so I'm not going to go that much of a detail in this. So t prime to 0 dt will just give you what? So I have this k over m, so that will just give you t prime. And now, what do you have over here? dv over v. So I don't need any substitution. I will just integrate this. And the integral of dv over v will just be ln v. Alright, that is the integral of that function. And what should I do? I should substitute it with the upper and lower boundaries. And once we do this, what are we going to get? Negative k t prime over m is actually equal to ln. I only have one variable already, so I will just substitute it with the upper boundary, which is v prime, minus ln, and you substitute with this v with the lower boundary, which is v0. And now you have ln v prime minus ln v0, which means we can write this down as in one ln function. And how is it going to look like? Ln v prime divided by v0, and I need to get rid of this ln. And to be able to get rid of this ln, what should I have? I should have the same e as a base, and this e and this ln will cancel out, but this guy's going to stay. So e to the power negative k t prime over m is actually equal to v prime over v0. And my v prime will become what? v0 times e to the power negative k t prime over m. So that is my velocity as a function of time. And they also asked for the velocity time graph. So that's your velocity, that's your time. Initially, I start with v0, but what's happening, it's going to the right, but the force is applied to the left. So what's going to happen, and it's not going to go linear because this is a function of velocity, so that's going to go exponential. And at the end, you're going to stop because there's nothing that is going in the right direction, so eventually you have to stop. So that is going to be part B. And in part C, they're asking for one more step forward. So they're asking for the position. Alright, and what is going to be the position of the object? So if you think about it, x and v, how are they related? So we have our velocity function and we are trying to find the x function. So we need to go from velocity to x, right? Because we have velocity function and we are trying to figure out my position function this time. So I need to go backward. And if you're going backward, remember from my calculus review as well, that is going to mean integral. So what does that mean? Your position function will be the integral of your v function with respect to time. And what is my v as a function of time? v0 times e to the power negative k t prime divided by m times dt. So at this point, I would just like to get rid of this prime because this t prime is just representing any time t. So it's basically as a function of time. So that time is any time t. So over here is a variable, the same thing. So I just would like to get rid of that prime. Again, it just means any time t. So here we're going to use this as a variable. So now we need to figure out my initial and final positions. So what is my position at the beginning when time equals 0? I start from 0 position, and where do I go? Any position x. Sorry. We are talking about time. So we're going to start from 0 to any time t again. All right. So again, our variable. All right. So now we need to figure out the boundary. So what is this is our variable, so we are talking about the variables of that time. So I start from time 0 and then I go to any time t. And again, we can put t prime, it's up to you. Alright, let's put t prime again. And again, this t prime just to not get confused, alright? Normally we just put t there. Alright, now, so how are we going to take the integral of an e function? So, all you have to do is actually look at the coefficient of t. So what is the coefficient of t over here? It is negative k over m. Alright, so that's your coefficient. So integral of this function is reverse, flip the coefficient, okay? Flip the coefficient. So v0 is just v0 because it's a constant. v0. And when you're taking the integral, flip the coefficient. So it's going to be m over k. But you have this negative, so I'll just take it to the front. Negative v0 times m over k. And you multiply it with the original function. Alright, normally you can use a chain rule to integrate this, but I am not going to go through this. I will just give you the shortcut. So all you have to do is take the coefficient of time t and then you flip that coefficient. And you put this, like multiply the exact same thing, this function with the flipped coefficient. That's all I did. So v0 was there, e to the power negative kt over m, it's there. So all I have added is this negative m over k. And this is the integral, so I need to plug in my initial and final conditions, like boundaries. So my function is, let's put this guy a little bit nicer. Well, you can't really put that any nicer. That negative will stay there. Negative v0 m over k times e to the power negative kt over m. And I go from 0 to t prime. So what am I going to do now? I am going to replace this t with t prime and 0. So negative v0 m over k, e to the power of k. Instead of t, I put t prime over m minus same function, except instead of t, I will put 0. So negative is from the equation. Remember, upper boundary minus lower boundary. Then I have this extra negative from the equation itself, v0m over k, e to the power negative k times 0 divided by m. So what am I going to get from here? 0 times k is 0, 0 divided by m is 0, e to the power 0 is just 1. And 1 times negative v0m over k is negative v0m over k. You have negative negative, so you're going to have positive. So my position function will become what? Again, 1 times this is just this, and then you have negative negative, so that will become positive. So my function will become v0m over k, this guy, positive, so I brought it to the front. And I have this negative right here, and then I will just write down the rest. v0 m over k times e to the power negative k t prime over m. So this is my position as a function of time. Alright, and here again, you can just get rid of this prime, same thing. So that is my position as a function of time. And what are they asking for? They are also asking for the graph of this guy. And what will be the graph of this? So remember, you are starting with 0 position. So you're going to start from 0. And at the beginning you have some velocity, but your velocity is slowing down. And at the end it stops. Which means you are going to go faster at the beginning. So that means you're going to take more distance over time. But as time goes on, your velocity will slow down. And at the end, you are going to stop. So that is your x time graph. And at the last part, they're asking for the actual position of the object. So my x as a function of time is already v0m over k minus v0m over k times e to the power of negative k t prime over m. So they tell you find the x at infinity, when time is infinity. So all you have to do is replace this t prime with infinity. So if you do so, let's see what we get. X v0m over k minus v0m over k times e to the power negative k infinity divided by m. So what is this going to give me? So infinity times a number is infinity, and divided by a number, again infinity. So this entire thing, except the negative, because negative is something else for powers. So this guy is still infinity. But what do you have over there? You have a negative. And what is the meaning of that negative? Let's write this down again. v0m over k, negative v0m over k. So negative power, remember, is writing it in the denominator. So that means e to the power of infinity. And now let's think about this. Power of infinity for any number will give you what? It's an infinite number, so you're multiplying the same number again and again, like until infinity. So that means this guy is going to give you an infinite number. And if you divide a 1 or any number with an infinitely large number, what are you going to get? If you divide a number with an infinite, you're going to get 0. Because think about it, you have a piece and you divide it to infinite numbers. So that means the piece that you're going to have technically is none. And if you multiply a number with a 0, what are you going to get? So this entire thing will become 0. So my position at the end will become what? This is k v0m divided by k. So basically, if this is the force that you apply, after v0 times m over k, this object is going to stop. So basically this number right here is going to be v0m over